Welcome to David Alexander Maths Tuition. This is chapter 2G on solving modulus problems. Okay, so here's our first example. For the below function, sketch the graph and then state the range. So that the f of x is 5 modulus x take away 3. So first of all, let's just think about the graph of y equals x. Well, we know that y equals x. That is nice and easy. Y equals x goes straight through the origin like so. So this is the line y equals x. Now, so let's change this to y is the modulus of x. So remember, anything that is beneath the x-axis will be reflected. So this will now head off in this direction and we can ignore that bit there. Okay, line is a little bit wobbly, but it doesn't matter. Right, so let's now do a little transformation. So it's y is 5 times the modulus of x. Well, if I'm comparing it to y as the modulus of x, it's going to be similar but steeper. So it's, this might not be particularly accurate. So at the moment, it looks like so. Okay, so that is y is 5 times the modulus of x. And so therefore, 5 times the modulus of x take away 3 is this graph moved down 2. So at the moment, the key thing is that this, well, it's not a turning point, this vertex here is 0, 0. So if we move it down 3, then it is going to be 0, negative 3. Okay, so this is the minimum point here. So this is now my sketch. So probably a better way just to do the sketch would be if I just delete all of this. So it's an arrowhead. There we go. And we know that this is negative 3. Done. So that is my sketch. So worth building it up by doing y equals x, y equals the modulus of x. I mean, hopefully you can go directly to y is the modulus of x. 5 times the modulus of x and then drop it down by 3. So what is the range of the function? Well, x can be any value, but y can't be any value. Y is any value that is negative 3 or above. So y is greater than or equal to negative 3, or the f of x is greater than or equal to minus 3. Okay, so here's a similar example. So I'm going to focus first of all on drawing a sketch of y equals x plus 3. So it's got a y-intercept of 3. It's got a gradient of 1. So it's going to be coming down like so. And as it's the modulus of x plus 3, it can't go beneath the x-axis. So that's going to reflect off in the opposite direction like so. Now, if this is the modulus of x plus 3, the modulus of a half of x plus 3 is going to be fairly similar, except it's just going to be not quite as steep. And for the purposes of this sketch, we could just call that is the half of the modulus of x plus 3. However, one thing to be aware of is that if it's the modulus of x plus 3, then this is going to be the 0.03, and a half of the modulus of x plus 3, this would now be 0, 1.5. But the key thing is it's not really affecting this point here. So this point here is negative 3, 0. Okay, so that is where the graph bounces off the x-axis. Now, because it's the half of the modulus of x plus 3 plus 4, what I'm doing is I'm shifting this whole graph up by 4. So this point, negative 3, 0, will now become negative 3, 4. Okay, so there we have it, negative 3, positive 4. So therefore, any y value must be 4 or greater. So y must be greater than or equal to 4, or the f of x must be greater than or equal to 4. So that is the range of the function. Okay, so I'm going to start off by just doing a little sketch of x plus 2. So it's cutting through at 2, it's got a gradient of 1, and it would look like that, except it would keep going down. But because it's now, I'm going to do the modulus of x plus 2, it's going to bounce off in the opposite direction. Now, 5 times the modulus of x plus 2 would be quite similar, except it would be a lot steeper. The y-intercept would change, but this point here, which by the way is negative 2, 0, won't change. Now, we want minus 5 times the modulus of x plus 2, so what that is going to be is a reflection of this V shape in the x-axis. Again, it's still going to have that point of negative 2, 0. And then we're going to do the minus 3, so we're going to drop it down 2. So minus 2, 0 will become minus 2, minus 3. So this point here is -2, -3, and that is the maximum y value. So we can see that the y value will be anything that is -3 or below. So y is less than or equal to -3, or the f of x is less than or equal to -3. So again, just build it up from x plus 2, do the modulus of that, and just remember, if you've got a minus in front, then that is just flipping it in the x-axis there, and then applying this translation either up or down. In this case, it is down. Okay, so here we're sketching the graph of y equals the f of x, so it's 3 times the modulus of x plus 1. So x plus 1 will go through at plus 1, and it will hit this point here, which is, it doesn't really matter actually, but it will be -1, 0. So 3 times that is just going to be similar, but a lot steeper. Again, as it's a sketch, it doesn't really matter. We could have called that original line we drew 3 as the line of 3 modulus of x plus 1. And now I'm just going to drop it down by 3. So if I just draw this over here, so this point here is now dropped down by 3. There we go. And where is y greater than the f of x? Well, that is going to be above this line. So this is the area that satisfies y is greater than or equal to the f of x. Now, we also need to bear in mind whether these lines should be dotted or they should be thick, and in this case they should be thick because it does also equal y is greater than but also can equal the f of x, so therefore the line remains thick rather than dotted, which would be y is simply greater than the f of x. Hopefully you remember that from back in the GCSE days. Okay, so parts 1 and 2 we've done loads of times before. So modulus of x plus 3 would look like so. 3 times that is just going to be similar but a bit steeper, and then we're moving it up 2. There we go. So originally we've got the y-intercept of 0, 3, so this is -3, 0, and this -3, 0, which is the point where it's reflected off the x-axis for the modulus of x plus 3, and also 3 times the modulus of x plus 3, but we want to add 2, it's going to be -3, 2. So this point here is -3, 2. So there is, slightly dodgy axis there. So -3, 2. So we can see that y can be any value that is 2 or above. So y is greater than or equal to 2. Okay, so we're solving the equation. The f of x is the f of x, this stuff here, equals 5x plus 2. Okay, so 5x plus 2 goes through at plus 2, and it's got a gradient of 5. So it's pretty steep. So what we can see is that it's hitting this part of the line here and not this part of the line here. Now the equation of this part of the line, well, this is the original, well, it was the x plus 3 multiplied by 3 plus 2. So the equation of this line is simply 3 lots of x plus 3 plus 2. So that's what we're going to set our 5x plus 2 to. If we thought for some reason that it was going to hit this line here, then we would set it to -3 lots of x plus 3 plus 2 equals 5x plus 2. But here we can definitely see that it's the 3x plus 9, or 3 lots of x plus 3 plus 2 that it's connecting with. So let's expand the brackets and just rearrange. So that's going to be 3x plus 9 plus 2, so plus 11 is 5x plus 2. Take away 2 and take away 3x from both sides. That's going to be 9 equals 2x. So therefore x is 4.5. Okay, so the point where these two lines meet is where x equals 4.5. So we have solved it. Okay, so this question is a little bit harder. We've been told the equation of the f of x equals the g of x has no real roots. So these two lines do not meet. What I'm going to do is I'm going to work out what is the value of k where they do meet. if they did meet and there was one root, if there's one solution, what would the value of k be? Right, so what I'm going to do is I am just going to do my sketch of the 2 times the modulus of x, take 3 plus 5. So the modulus of x minus 3 would look like so. In fact, my sketch of 2 times that, I can also say looks like that as well. And the key thing here is that we've got this y-intercept of 0, -3. So if I'm moving this up by 5, then my sketch will now look like this. So this is the point 0, 2. Now, I know the question says no real roots, but if it says one root, then this line, a third of x plus k, oops, sorry, that's supposed to just hit that point there. I'll make that point just a bit bigger. There we go. So what is k if a third of x plus k goes through 0, 2? Well, it's going to be a third x plus 2. 1/3 x plus 2 goes through the point 0, 2, because this number here is our y-intercept. So therefore, what is k if there are no real roots? Well, k must just be a little bit less than 2. There we go. So k is less than 2. Y equals 1/3 of x plus anything that is less than 2 will cut through the y-axis at a point that is slightly below, or maybe massively below 2, but it will not be 2 or more. If it's 2, we get one solution, and if it's more than 2, we'll get 2 solutions. So we know the equation of the line is y is -9 take away x, and it goes through the point minus b minus 7. So let's just sub these in. So y is -7 is -9 take away x, which is -b, minus, there we go. And of course minus b is plus b. So what I'm going to do is I'm going to add 9 to both sides. So 9 take away 7 is b. So therefore b is 2. There we go. So b is 2. We are done. And if you want, you can just substitute 2 back into this equation and work it forwards, and just to check that just check the values match up, and of course they do.